Back to the inverted pendulum that's stabilized with a reaction wheel. I've made a couple of little changes. First is I got the wires moved from up top, where a tiny little force at that distance from the hinge, from the center, can exert a considerable torque for this system. So I put them down here where they're less troublesome unknowns, and also playing around with a slightly different flywheel that's a bit heavier. It's 3D printed. It was made for, what was it, 12, 13 pennies, 8 slots. It was made for 102 altogether, but that was way too heavy, so I chopped it down to, I think I got 3 times 8, 24 pennies in there now, 100 some grams. Anyway, let's turn the motor on. I've had it running for quite some time. Motor is running. It has a considerable wobble, which actually has the effect of making it move. It lurches just, when it does that wobble, it falls over a bit, like it's shaking the hinge free or something. Let's give it some disturbances. Standing up by itself on a hinge. I think one of the tricks is to keep the motor speed pretty low. I had trouble with the accelerometer just stopped working. Is I think this encoder, the motor encoder here, is 512 counts per revolution. If it gets too fast, there's just too many interrupts coming into the poor little Arduino, and the accelerometer drops out, and that's it. But nice slow speeds, a little more mass in the flywheel helps keep it slower. The motor can torque it over easier. Seems to be doing alright. Oop, that did it. Number 2.